Okay, these are more of the mid-chapter P practice. And now we've got some more complicated operations. So again, as I said before, you should be trying these on your own, go through your work, and then go back and check. If you do that, then you're going to really find out, what you know. So you can do an assessment on your own work. Make sure you understand what's going on. And then if you don't get exactly the right answer, you can go back and check my solutions, check and see where you made your mistake, and then try it again. That would really help. Okay, so what we have is we've got this monomial times this monomial squared. So the first thing I have to do is take care of my exponents. So I've got exponents here. So this just becomes the same. I just rewrite this. And then I just square this out. So it's going to be 2 squared. And then remember, we multiply exponents. So it's going to be 3 times 2. And this is going to be x to the 2 times 2. So I wrote this step out just to kind of remind you what's going on. And then again, I rewrite this again. So this stays the same. So this has not, just rewrite this. We have to do a lot of rewrites in math. And then 2 squared is 4. 2 times 3 is 6. 2 times 2 is 4. Now you might want to skip some of these steps. That's fine. Just be careful though. Okay, now when I multiply this out, remember now 4 times 4. So what I did was I just put the numerators all together to show you these steps. So I had 4 times 4, x squared, y, and y to the 6th. So I lined up all my factors, like factors next to each other up on the top, and on the bottom I got 3, and then y squared x to the 4th. Now 4 times 4 is 16, x squared y to the 7th, and then I had 3, and I kind of put my factors in x, y form, or alphabetical form, so I have x to the 4th, y squared. Now the 16 over 3, nothing's going to happen. Now on the bottom I've got 2 on the top and 4 on the bottom. So 2 on the top will cancel with 2 on the bottom. So that leaves me with, x squared, and this is like x squared times x squared. Those x squares cancel, so I just have x squared on the bottom. And here I've got 7 on the top, 2 on the bottom, or we can think we're dividing, we subtract. What's 7 minus 2? 5. So I end up with 5 y factors on the top. And again, you can think of this as 2 x factors, xx and xxx. So you could think of it like that. If that bothers you, that's another way to kind of, break it down. In other words, I can think of this as x on the top and 4x's on the bottom. And I can think of this as 7y's on the top. 1, 2, 3, 4, 5, 6, 7, and 2y's on the bottom. And these 2x's cancel and leave me with just 2x's on the bottom, and 2y's here cancel with 2y's and leave me with 5y's on the top. So that might be another way to think of it. Hopefully that helps. Okay? On number 10. Okay, again, what we want to do is we want to do powers first. So what I did was I multiplied each of these. So I multiplied -1 times that power, -3, and -1 times -2, and then -1 times -3, and -1 times 2. Sometimes it's better just to multiply these out when you have negatives, because sometimes a negative times a negative becomes a positive, so it straightens things out. So that's what I did. So this became -3, and that's a +2. That became +3, and that became -2. Now remember, we don't want any negative exponents, so if it's negative, we move it in the opposite part of the fraction. So this was -3, so what I did was I put this in the bottom. I left the y squared alone, but I put the x to the -3 in the bottom with this x cubed. So I leave the x cubed alone. And then I leave the y squared up on the top, and then I put this one. So I underlined what I was moving. So I moved this from the bottom to the top. So remember, when we move the exponent from one part of the fraction to the other part of the fraction, we change the sign of the exponent. So this went from x to the -3 to x to the +3. This went from y to the -2 to y to the +2. And I left these positive ones where they belong. And then when I multiply, what's 2 plus 2? 4. Remember, when we multiply, we add the exponents. So 2 plus 2 is 4, and 3 plus 3 is 6. Okay? So be careful, you add the exponents. Okay? And then number 11, we were adding radicals. And remember, they have to have the same index. In this case, the index is understood to be 2, and the same radicand. These don't have the same radicand, but they always have to be simplified. And these kind of violate no-no number 1. We have a perfect square factor under each of these. The perfect square factor of 18 is 9. 9 is a perfect square. 9 times 2 is 18. A perfect square factor of 8 is 4. 4 times 2 is 8, and 4 is a perfect square. And a perfect square factor of 50 is 25. 5 times 5 is 25. And 25 is a factor of 50. So this is the same thing as 18, 8, and 50 written with their perfect square factors. And then we can take the square root of 9 is 3. The square root of 4 is 2. Now that 3 comes down. And the square root of 25 is 5. These are the same. What's 3 times 2? 6. And now I can add these up. I can say 3 plus 6 is 9 minus 5 is 4. Or you could think of just factoring out the negative 2 or using the antidistributive property, going backwards. Okay. And then you could have this. Or the distributive property. Pardon me, I'm just kind of working it backwards. Take the square root out. So it's the distributive property. We're just distributing the square root out. And we have left 3 plus 6 minus 5, and that's still again is 4. Okay? Those are a couple ways to think about that. Hopefully that helps.